Okay, welcome to this explainer. Today, we're diving straight into the invisible, everyday chemical battles happening right inside us, and, well, all around us. We're going to take a really close look at the fascinating world of acids and bases. Specifically, we'll focus on how they interact, how they neutralize each other, and how this one incredibly simple chemical rule effectively saves us from some pretty uncomfortable situations on a daily basis.
Let's get right into it with Section 1, the acidity problem. To truly understand this chemistry, let's start with a highly relatable physical sensation. We've all been there, right? You eat way too much at a great dinner and your stomach goes into total overdrive. It actually produces excess hydrochloric acid to help break down all that food. But that excess acid causes a familiar, super uncomfortable burning pain that we call indigestion. So how does taking a simple, chalky antacid tablet provide almost instant relief to that burning sensation?
Well, the secret to your relief isn't magic. It's actually a very specific chemical process where two opposing elemental forces effectively cancel each other out. It's called chemical neutralization. And to understand exactly how that stomachache just miraculously disappears, we have to identify the two major players involved in this reaction.
Which brings us to Section 2, acids and bases defined.
Before we look at the solution to our chemical conflict, we first need to define the two warring factions. And there is a stark contrast between these two groups of substances. On one side, we have acids. You know them well from everyday life. They taste sour, like the citric acid in lemon juice or the acetic acid in vinegar. In a lab setting, they turn blue litmus paper red. And chemically speaking, they produce hydrogen ions. That's H+, when dissolved in water. Now, on the totally opposing side, we have bases. These are bitter to the taste and feel strangely soapy to the touch. They do the exact opposite to indicators, turning red litmus paper blue. But most importantly, bases generate hydroxide ions, OH-, in water. So you've got two distinctly opposite characters with completely different behaviors.
Let's move on to Section 3, the neutralization reaction. What actually happens when opposites meet? You might think that this clash results in some messy, unpredictable explosion. But rather, it leads to a clean, elegant process called neutralization. Neutralization is simply the reaction between an acid and a base to give a salt and water. During this process, both substances actually lose their extreme, often corrosive properties. The acidic effect is completely nullified by the base, and vice versa, bringing the whole environment closer to a safe, neutral state. So, the absolutely crucial point here is this simple but powerful equation. A base plus an acid will always result in a salt and water. For example, if you mix sodium hydroxide, which is a really strong base, with hydrochloric acid, they neutralize to create sodium chloride. And sodium chloride is literally just regular table salt, plus, of course, water. Let's zoom way in for Section 4, the invisible ionic dance. Think about what's actually happening to those specific, highly reactive ions we talked about just a few moments ago. Because this is the true aha moment of neutralization. The potentially dangerous acidic hydrogen ions, the H+, and the basic hydroxide ions, the OH-, find each other. They combine directly together, and what do they form? H2O, perfectly harmless liquid water. I honestly think it's brilliantly poetic. These two highly reactive, sometimes hazardous components perfectly lock together to create something as simple and vital as water. The acid loses its bite, the base loses its sting, and they leave behind neutral water and a salt. It's essentially nature's way of keeping things in perfect balance. However, it's not all perfectly calm when we're dealing with chemistry. We definitely have to note that dealing with concentrated forms of these chemicals requires serious respect. The process of dissolving these concentrated substances in water is highly exothermic, and all that means is it generates intense, rapid heat. Because of this intense heat, there are strict safety rules for dilution. You must always add the acid slowly to the water with constant stirring. You should never ever add water directly to a concentrated acid. If you do, the sudden heat generated can cause the mixture to violently splash out, potentially causing severe burns. The extreme local heating can literally cause a glass container to shatter. So, safety is paramount when handling these powerful chemical combatants. All right, bringing it all back home with Section 5, real-world neutralization. Now that we understand the invisible ionic dance and the crucial safety rules, let's see how nature and humans use this exact chemical reaction every single day. Remember that stomach ache from the beginning of this explainer? When you have indigestion from excess stomach acid, you take an antacid, like milk of magnesia. Well, milk of magnesia is a mild base, and it neutralizes the acid. Or if you get a painful bee sting, which actually leaves an acid on your skin, a traditional remedy is to apply a mild base, like baking soda, to neutralize the sting and get fast relief.
And it goes even further than that. Your daily habit of brushing your teeth relies entirely on this chemical principle. Bacteria in your mouth produce acids by breaking down sugar and food particles. If the pH in your mouth drops below 5.5, your hard tooth enamel starts to corrode. But using toothpaste, which is generally basic, neutralizes those corrosive mouth acids. It literally saves your enamel and prevents tooth decay. And you know, nature is perhaps the most clever chemist of all. If you're hiking and accidentally touch a stinging nettle plant, its tiny hairs inject methanoic acid, causing a terrible burning pain. But traditionally, people rub the area with the leaf of a dock plant. Why? Because the dock plant, which often grows right beside the nettle in the wild, is naturally basic. Nature often provides a basic neutralizer right next to a painful acid, restoring balance. Which leaves us to wonder, what other incredible chemical remedies are quietly waiting to be discovered just outside our doors?